Alright guys, so last up that we're going to look at for today is quadratic inequalities. And what quadratic inequalities are is it's very similar to what we've been looking at with x squared and everything, but now instead of having an equal sign we're going to have an inequality symbol, so greater than, less than, something like that. So how do we do this? Let's take a look. So here's our xy axis. Let's put a parabola on here, something like that. And this could be any parabola. The equation could be whatever. It's x squared plus 5x minus whatever. It can be anything. For now, let's just call it f of x. So this is the function. And it could be any. There's an infinite number of ways we can write the equation of a parabola. But let's just call it f of x right now. So here's how this works. What they're going to ask us to find out is f of x is greater than 0. When is f of x greater than 0? And here's how that works. We take this graph and we cut it in half at the x-axis. Whenever the graph is above the x-axis, that's when it's greater than 0. So if we cover up like this, these are the times it's greater than 0. Whenever the graph is below the x-axis, that's when it's less than 0. And it's below the x-axis, less than 0. So this right here, that's when it's less than 0. And the way we would write the answer to these is we write them in interval notation. Okay, because so if we look at, say, greater than 0, we'd say all the way. So when is it greater than 0? So between these intervals here. So we'd start all the way from the left. We'd say, okay, well, this line kind of continues on all the way to infinity. So it'd start from negative infinity all the way up to here. This point right here where it crosses through the x-axis, all the way from infinity all the way to there, to that point. This part is above the x-axis, so we would give the interval from negative infinity to there, to that x value, that point. And then it's below 0 for a little while, but then we're looking at greater than 0. So starting from here now, from this x value, whatever it is, all the way to a positive infinity, would it be greater than 0? Alright, so really the only thing that matters to find is the x-intercepts. Once we have the x-intercepts, we know when it's above and below, or when it's greater than or less than 0. So let's come over here and take a look. This is number 4 on page 314. And so what they give us is here, this is my lovely recreation of the picture in the book. They give us a parabola, it's facing down, and they give us this point here, negative 1, 0, this point 4, 0, and this point 1.5, 5. And so they ask us two questions actually. They say, when is g of x, they call the function g of x, when is g of x less than 0? Okay, so if we look at this, when is it less than 0? So when is it below the x-axis? Right there. Alright, here and here. So we write this in interval notation. If we start from over here, it's starting from negative infinity, it's already below 0. And it keeps staying below 0 all the way to this point here, negative 1. So all the way from negative infinity to negative 1. Not including negative 1, because then it would be equal to 0, and we don't have that. We just have less than 0. So all the way from here to there, it's less than 0. And then for this little this interval here, it's above 0, so it's greater than 0. So we're not going to count this part of it. But then picking up back again here, starting from 4 and beyond, now it's below 0 again. So we went from negative infinity to negative 1, but now starting from here down, from 4 to positive infinity, it's also below 0, and we're going to union these together. So negative infinity to negative 1, it's below 0, and then from 4 to positive infinity, it's less than 0. Okay, that would be our answer for this. That would be our answer for when is this less than 0. Now, when is g of x greater than 0? Well, that would be like well, it's actually greater than or equal to 0. So it's whenever it's above here. So over here, we know it's below 0, below 0. Starting here, it's greater than or equal to 0. So now it's or equal to, so we're going to use the bracket instead. So we're going to say, here's the bracket. So starting from negative 1 over here, so negative 1, it's greater than 0, greater than 0, greater than 0, greater than 0, all the way to there. So negative 1 to 4, and we'll include the 4 because it's greater than or equal to 0. That's the big difference here. If it's just less than or just greater than without the equal to, we use the brackets, or we use the parentheses. If it's or equal to, then we use the brackets. Okay? So that was when it was greater than 0, so when it was above the x-axis. Notice we had the vertex that gave it to us, but we never really needed it. because even though here it was kind of increasing and here it was decreasing, it was still above the x-axis the whole time. So we didn't really even need that. We just needed these. As long as we had the x-intercepts, we were golden. Okay, that's how that works. The most difficult, and I use difficult kind of sparingly because these aren't very hard, was this one right here. This is like number 8. And it says, here's our equation. Now, all they gave us is the equation. They didn't give us a graph, okay? Then they say, when is this greater than 0? So we do the same thing. If we know the x-intercepts, and then we know what intervals we're looking at, okay? So the first thing we have to do is we got to solve this. Let's pretend for a second that there's an equal sign on this. So x squared plus 3x minus 10 equals 0. Let's go ahead and solve this the way we would normally solve it. So we got to factor it. So here's x, negative 10 and 3, so what's that? Plus 5 minus 2. Alright, and then so set each one equal to 0, x plus 5 equals 0, and x minus 2 equals 0. And then we solve each one, so we get x equals negative 5, and x equals 2. These numbers we get, these will be our x-intercepts. Okay, so if we put it on the graph here, we got our x-intercepts are negative 5 and 2. So negative 1, 2, 3, 4, 5, and a positive 2. 1, 2. Does the parabola open up or down? Correct, it opens up because it's positive right here. So I know it's a parabola that opens up that goes through these 2 points. So it's going to look something like this. This is totally not where the vertex goes, but I don't really care. All I care about is these points right here. This is the point negative 5, 0, and this is the point 2, 0. All right, and the rest of this doesn't matter to me because all I care about is this, because this is like kind of where it decides: is it above 0 or is it below 0? All right, and so the original question was greater than. When is this greater than 0? So okay, greater than 0, that means above the x-axis. So let's go ahead and write it out. It's greater than. It's not greater than or equal to, so it's just greater than. We're just going to use the parentheses. So let's see. So when is it greater than 0? Looks like it's from negative infinity all the way to negative 5, not including the 5 because of the negative 5 because it's just greater than. Unioned with here it's below 0 or less than 0, so we don't count this stuff. But then starting here, picking it up back here, it's above the x-axis, so we go from 2 to a positive infinity. And there's our answer, from negative infinity to negative 5 and to infinity. All right. So the big thing here was we have this. Let's solve it, and that'll give us our x-intercepts. And then we can look at the graph, and we can look back at the original question: is it greater than? And so we can tell when is it above the x-axis, when is it below the x-axis, and write our answer in interval notation. Okay. And that's all there is to 4 or 5, guys. All right. Good luck.